Hello and welcome. My name is James Edward Gray II, and you are watching a Codalyzed video. Today's topic is the lesscode movement and what we can learn from it. I want to begin by sharing details about a journey of the mind I've embarked on recently. After that, we'll dig deep into some code and learn everything we can from dissecting it chunk by chunk. We've got a lot to cover, so let's get started. I've been exploring the lesscode ideas lately. And that really all started for me when I found this post on Reddit by Michelle Martins. The question was asked, what libraries can I read that are under 100 lines of code? And Michelle's answer was to list several of his own libraries that he had built, many of them in Ruby, but some in other languages as well. And when I discovered this post, I found it interesting that he had this repertoire of libraries that were small, and I started digging into many of them, and just had a glorious time reading through all of this code and figuring out how things work. This discovery caused me to re-listen to Michelle's episode on the Ruby Rogues podcast, and it's pretty insightful. Michelle challenges the rogues with some ideas in that episode that are difficult for them to accept, I think. And they go back and forth over a few of them, especially over concepts like Flash and Rails. And I listened to it with kind of a new perspective the second time after having read through all these libraries, and I really got a lot out of it. After that, I started hanging out in the lesscode channel on Freenode, and that's a place where conversation happens about code in general, but also participants share links of various things that they've found that kind of embody these ideals of lesscode. A lot of those links get collected on a subreddit, and you can scroll through those there and see several. And I've found some links there and other places that have driven these ideas farther for me. One that really got me thinking was this talk about the practices we get into of always doing the same things because those are the things we've always done, but what really are the costs of making those decisions, and are they good ideas, and things like that. It's very thought-provoking. Finally, I read a thread, an old LinkedIn thread, about one of Michelle's libraries, Cuba, and it's a very interesting thread. One of the few places on the internet where I would tell you to suspend the rules and actually read the comments. It's a back and forth about a company considering the consequences of using a library like Cuba versus something that's, road tested, we'll say, like Rails. And there's really good back and forth on that, and people struggling to understand the trade-offs involved, and it goes pretty deep. The link I have here is a link to kind of a summary of that on Michelle's own blog. If you want to, it includes a link to the actual thread, which is a great read as well. So the lesscode movement is, in my opinion, about what we can do with significantly less code, what we can accomplish using the minimal amount of code aimed at a task. And we're often talking about libraries here that are 50 lines of code, some more, some less, but what are the smallest units of usable material in the source code world, which I think is an interesting thing to consider. And using these libraries has many implications, of course, in things like maintenance and understanding your tools and things like that you can probably get from these resources that I've given you and looking into them yourself. But another thing that's amazing about these tiny libraries that accomplish something significant is that they turn out to be about the best teaching tools around. You can dig into these libraries and figure out how they work and play with them and experiment with them because you're not in so far over your head that you're just trying to keep your footing as you find your way around. So I want to do that. I want to look into some of these libraries, Michelle's and others, in this and future episodes. So here's some code. The first library I want to look at is Moat, which is a small, about less than 50 lines of code templating framework. And I like it because it lets you see how templating frameworks, including even more complicated ones like ERB, generally work. And I think it's great for exploring those ideas. So all I've done here is pull the code off of GitHub, and I'm taking a look at it now. And the very first thing I would like to do, seeing that there's a test directory, I would like to see if I can get those tests running. And my reasoning for that, before doing anything else, is that I want to be able to read this code in kind of an active reading style, meaning that I want to be able to change things, tweak it, put in print statements, or do whatever I feel like I need to do to understand it. And the easiest, most reliable way to be able to do that is to be able to run the test and see if I've broken anything in doing that. So that's the first thing I would like to do. A lot of times with a Ruby project, you would have a rake file in here. This one does not. You can see it's not in here. Instead, it has a make file. And so I would expect that I could run a bare rake and get the test to go. It doesn't look like that's the case this time. Make may solve that purpose, but it may solve other purposes, and I'm leery to jump down the rabbit hole. So the first thing I'm going to try is just see if I can figure out the tests manually and get them to work. So I know there's a test directory. Let's take a peek at what's inside of it. And it looks like probably 2 data files and 1 actual test file, which is great news, hopefully easy to execute. So let's just try executing that test file and see what happens. Okay, so no dice. We got an undefined method error for a scope. Now this is interesting for 2 reasons. One, I expected if I saw an error to see a load error. And I would have expected that it was going to use some test framework that I don't have loaded or whatever. This project also doesn't have a gem file. I'm not exactly sure why that is. It's pretty common now for most projects to have a gem file. I remember when I looked at this one on GitHub, it hadn't been updated for about 4 years, which a lot of people might think, oh, it's dead. But a lot of times with these small libraries, these tiny bits of code, it's not so much dead as done, right? It's that it doesn't do enough to have a considerable number of bugs in it or need large numbers of changes. And the idea is that we don't want to add a ton of code over time. So it could just be stable and not necessarily dead. But either way, it doesn't have a gem file, maybe because of the age when that was less common, or the author's just not a fan. But I would expect some missing dependency, but that should probably manifest as a load error. Here we have an undefined method scope. And there again, if I expected some kind of undefined method error, I'd maybe expect something like describe for maybe RSpec or something. So it's clear I don't know what's going on here. I could open the test file, and that's definitely a way to go if I have to. But I'm going to assume there's a dependency since I don't recognize the word scope, and I'm going to try to figure out what that is. I see 2 options over here. One is that there's this .gem file I can open, and I believe that's for gem sets. which I don't use. But it's nice to be able to open this and see what would be used in the gem set. Also, there's the gem spec that I could open and take a look at to try to see what the dependencies might be. So let's take a look at those two options and see what we get. So first, the .gem file. Yes, so we see some dependency here called Cutest, which is not something I have heard of, but definitely sounds like a potential testing framework. Let's open the gem spec as well. And you can see here toward the very end, there is this added development dependency Qtest. So these are probably the testing dependency that's missing. So I'm going to go ahead and see if I can just install the gem and see what happens. So gem install Qtest. Hopefully that is just going to work. Okay, it appears to have installed and we're good there. So now we meet the dependencies. Now we know that we're going to have to know how to run it, which we currently don't. And again, with the absence of the rake file, this time I'm going to go ahead and dip into the make file and see, yep, there is a make action that is a test action, and it's for running Qtest. So I think we are just going to try that right there. So let's do make. Look at that. All right, that's it. We have a passing test suite. They're running, and now we can look into this library with a little bit of confidence, knowing that we can tweak things and run things and test these, run these tests, and hopefully use them to see if we've broken anything. So that's a great start. There's one more thing we should do before we actually dive into the code, just to set ourselves up for what we expect to see, and that's scan through the README. So I'm just going to open it up and take a look at what the author wants me to know about this project. The description here, that it's simple and fast templating engine, sounds good. There's some basic usage here we see, which looks very straightforward. One thing we notice is that there's two types of special meanings in templates, it seems. Lines starting with percent signs, and then the double braces for kind of interpolation, whereas lines starting with percent signs are more flow control. So those are the two different kinds of templating signals that we're aware of. Let's see. Yep, assignment, comments, block valuation, that all makes sense. Parameters, so we can pass parameters to them and fill those in. That makes sense. So you would need that for a templating language to be useful. Something about a helper. Looks like that may be kind of Rails-ish usage there. Template caching, we're not really going to worry about that right now. Oh, binary that's there that we'll want to look at. And how to install, we don't need because we've already done it. Okay, so you'll notice I didn't read too carefully in that case, but I just used it to get an idea of what we're going to see once we're inside the code, the kinds of things I'm looking at. And that's enough to get you started, enough to put you on the path. And then now it's time to open the code and see what we can see. All right, there's only one code file in this project. That's the main meat of the system. So we're going to open that up, and you can see that it starts with a big preamble. So it's actually smaller even than it looks due to copyright notices and stuff. But the main class is what we're interested in. And you can see down there the parse method that is the main entry point we remember from the usage. We had to skip past a quasi-scary looking regular expression to get that far. That's probably going to be important pretty soon. In fact, if you look at the first line of that parse method, we can see that whatever's given as the template is split on that huge regular expression. So maybe a great place to start is understanding this regex and what it does. For me, part of understanding a regex is making it more readable. So I'm going to try to do that. This is a fairly long regex. It won't fit on my screen with this large font that I'm using for screencasting purposes. So let's switch from reading the regex that we need to read to reading the regex that we would rather read. And to do that, we can just divide it up basically by the atoms. Those are pretty easy to spot in this expression. They generally have parentheses around them to capture the various groups. If not, it's usually just an escape followed by some kind of quantifier like a star or a plus. But we can just eyeball it, break them all apart, decide where things go, and that gives us our separate expression. But I did break the regular expression. I've inserted a ton of white space, which it will now try to match in between each of these atoms, and that ruins the whole point of it. So we should see test failures, which we do. Looks like qtest only runs to the first failure and then maybe quits, but that's fine. It tells us what we need to know and that the library is now broken. It's an easy fix. We can just put the regex into extended mode, which is Ruby's mode that allows for things like white space and comments inside regular expressions so that you can make them more clear. I can get away with that in this case because this regular expression, while it matches spaces, it doesn't refer to them using space characters. Instead, it uses more general escapes like \s, which will match any kind of white space, or specific escapes like \n for a new line character. So even though this matches against some white space in places, it didn't use exactly those characters, so there was no problem with breaking it up like that. And now it's easier to understand, with the only minor exception being that apparently Emacs isn't smart enough to recognize what I've done here. Oh well, on to breaking down the regular expression. The first chunk of this regex just matches the beginning of the line followed immediately by a new line. So in other words, that's a way to match blank lines. I'm not sure why exactly that's needed yet, but that's what the first chunk is for. Also, the new line is captured, so we'll have to take a look at that when we get deeper into this and see what that's used for. The second chunk should probably be more familiar to us. Again, it starts at the beginning of a line. It can have some optional white space after that, followed by a % sign, which is captured. And the % sign says that those are the lines, remember, from the usage that are for Ruby flow control, so they're completely treated as Ruby code. It can have some optional white space after the % sign, and then I would read that next expression as whatever else, right? 0 or more anythings conservatively, and so that basically means whatever else, and it reads that until it runs into a new line, or the capital Z escape means the end of the input, so the very end of the template. And the reason those are given as two different choices is whoever entered the template may not have put a return on the very last line, so that could also count as a line ender. So even though we're in multi-line regex mode here, where a period could match new line characters, this particular one doesn't. It only gets a line of input because we're using the question mark at the end of the star to make the matching conservative. It's not greedy, it's conservative. And so it will stop as soon as that next atom can be satisfied, which is the following new line, or the capital Z that tells us we've hit the end of the document. And that makes sense because those % lines, they only count to the end of the line, right? So we need to stop at the end of the line and assume that the next line is data again, the default for a template. So that's the one main escape. The third chunk is odd because we did not see that mentioned in the documentation, but it looks like there's another kind of escape in these documents. We'll have to see what the code does with it as we get further. But it appears to be a less than followed by a question mark. Remember, question mark has special meaning in a regex, so that's why it's escaped here. White space after that, then again, some content, and more white space, and then the question mark greater than. So it's kind of like a XML tag, a kind of XML tag. Again, we don't know what that is yet or what the purpose of it is. Like the one before it, though, notice in the one before we captured the percent, and the content here we captured the less than question mark and the content. So it looks like that first capture maybe to determine the type of thing we found, and the second capture being the actual contents itself. The fourth one we do recognize. That's the kind of escape, the second kind of escape from the documentation, the one that was basically interpolating a value. So the two braces, again, meaning in regular expressions, so they have to be escaped, and we capture those so we know what kind of tag we're dealing with, I assume. And then we have the same content marker we've seen before that can stretch across multiple lines. So can the third one stretch across multiple lines. That is how this is all broken down. But actually, this is a little bit of an unusual use of split, and I want to show you why that is. Let's jump into IRB here and take a look at that use of split. I think split's pretty common in Ruby code, and probably everybody runs into it. But this is a more unusual variation of how it's used that I don't see as often. So it's probably worth giving some special attention. So let's just say that we had some content, doesn't really matter what, and then some divider that we want to use to split that content up. If we run just this, we see what I think you would expect to see in that the dividers are all removed and we get the individual pieces of content. But split has this other behavior where if we capture the divider or a piece of the divider, then whatever is inside the captures will also be returned as content. So when we run this version, you can see that we get the individual pieces of data as well as the dividers in between. And we've basically used it to chunk up the data. Now, this can have some variations because you can choose what you capture in the divider. So let's say that we were going to change this regex to allow arbitrary white space. So we could make some optional white space, or sorry, that's not right. We could allow some optional white space or some optional white space on both sides of the divider, and those are not captured. So they are not going to be returned with our divider. And you can see that we still get the same thing, and the space has been trimmed. So now if you look at this regex again, what you have is these various kinds of dividers, these special lines that are divided out from the regular content, these interpolations of values that are divided out from the regular content. Everything that isn't part of these patterns is all going to be regular content or the template itself. And everything that is in these values, these are the places where magic needs to happen. Ruby code is in there, and it needs to be treated as flow control, or it needs to be evaluated and stuck into the document. But because of these parentheses that were used in these dividers, we're going to get pieces of those content back. And like I said, it looks like the first piece in any bit is the content that was, or the type of tag, and the second piece is the actual content. So it's just going to chunk up the template into all these pieces of input, and then we're going to be able to run through them, I assume, with some code we'll see later on to determine what that does. Now, this parser isn't perfect. It has some conveniences in that it's very easy to write and understand, but it has some difficulties, especially when it comes to escaping. So let's say we wanted to use moat to talk about moat, for example. And in doing so, we type a line like this where we have the escape sequences as part of our template. You notice that what we get here is a syntax error. And the reason is because obviously moat expects that stuff between the doubled braces to be valid Ruby code, and it's not. Therefore, it can't be parsed into the template, and that's a problem. But there's some ways we could get around it. Probably the most obvious solution is to get these delimiters to be part of the data instead of part of the template itself. The simplest change we can make to do that is to do something like this, where we're interpolating strings that happen to contain the content we needed. Now here I've only fixed one of the two occurrences, and by doing that, that actually gets the template to pass, because the first one will correctly look forward to the first doubled set of closing braces, and thus the whole first chunk will parse out correctly. With that first chunk gone, the only thing that remains is the last chunk, the last doubled set of braces, and because that doesn't have a matching pair of opening braces, that works. I'm leery to say that that works as expected, but more that it works by accident, I think, is a better way to describe it. So that's the state we're in now. I think it would be better to find a way to be able to put the data in there and know that it wasn't affecting the template. Let me show you the problem I'm talking about. If we make the same change to the other instance of the delimiter to treat it as data as well, we're back to a syntax error. Now the reasoning is that the first one still parses out correctly, but then you're left with the final chunk, and there it finds the opening braces, but the closing braces come in the middle of the data instead of at the actual end of the intended Ruby content, and that throws the parser off. So that's what I meant by works more by accident. It depends on which set of which braces you have and where, of whether or not it's going to succeed. But I would rather find a way to make it safe to put delimiters in anytime. Of course, we have Ruby, and Ruby is a very flexible language. So we can just look up the code points for these particular characters and then use normal Ruby string escapes to get those characters into our strings. By doing that, they won't look like the actual characters, and they will be totally ignored by the parser. And that completely solves our problem. So the moral is this parser is a little simple. There's a couple of gotchas with it that we may have to work around. I think one of the reasons I kind of brought this up and stressed it a little is that I could see you running into this by accident if you chose to interpolate some iterators and you nested a couple of them, just so that you had the ending braces at the very end. I think the parser might get tripped up. But I think that's going to be a pretty rare scenario. In that case, all you would have to do is put a space between the two ending braces, so they would be considered separately. The parser only looks for braces right in a row. And like I say, it's probably pretty rare. You may not run into it ever, but it's good to point out the limitations of a simple system like this, and the advantages as well. The advantages is that one regex and one call to split, and you are set. So it's definitely a huge trade-off. We've taken a good look at how the template input is chunked out into the various pieces, some of it being actual template data and others being flow control code or interpolations designed to insert values into the template. Now the next major concern is, how does this series of chunks of input get converted into some code that actually creates the desired output? And that bit starts about here. We've got another long line here that doesn't fit well on my big screencasting font. Let's do what we did last time and go ahead and break it up. That's very easy here. We can just use some simple string concatenation. And with that done, we should check the tests and make sure we haven't broken anything. And we can see that indeed we haven't. So this process of converting input chunks into code is kind of a literal one in this case. We can see that the code is slowly building up the Ruby expressions required to make proc, which is just an objectified block in Ruby. This proc takes 2 arguments, and it looks like there's a line of code in there to default those if need be. Then there's this iterator that runs through and does what appears to be some variable munging. We'll have to look at how that works a little more in a bit. Then there's the while loop, which is the heart of the process, and it looks like it ships those input chunks off one at a time, and for each one, it goes through and adds it to the Ruby code that it's building up, and how it gets added in depends on the type of expression that it parsed off. So that's kind of what we were expecting, as far as we remember seeing that the initial capture was always the delimiter, so the type of template expression, and then the second was the content itself. And finally, the proc has a normal ending, which completes the whole thing. That gets passed to the compile method, which we're not ready to look at yet. Before we move on, I want to talk about one tiny change that I think could make this code better. The conditional here is kind of a red flag, in my opinion, because it's a very common mistake to intend to compare 2 items with equals equals, and to accidentally only type 1 equals, which changes the meaning to assignment. Because this mistake is so common, whenever I see it done in the shorthand like this, where it's just been folded into an if, or while, unless, until, I assume it's a bug, and I think a lot of programmers do. And there's kind of a convention that's sprung up in Ruby to signal this isn't a bug. I know what I'm doing. I intended to do it. And that is simply to surround the expression in parentheses in those cases. Since the parentheses aren't needed on conditionals and loops in Ruby, and we don't tend to put them, the fact that we added that can be a signal to the reader, yes, I know that I only used 1 equal sign here, and that's intended. So it's just kind of a convention that I think helps people notice this isn't a bug and you know what you're doing. And I think making that change here makes the code read slightly better. Getting back to the proc, I want to see a visualization of the input I feed into it, the proc that's generated, and the output that produces. To do that, I'm going to make a simple change, and that's disable the compiling and have the parse method return the proc that gets generated instead. Now I'm going to go back into IRB and run a template through mode. The template I'm building here, I'm going to try to include all 3 types of common input. So just straight text that's part of the template itself, some flow control code to repeat something, and then some interpolations to get the values of variables. Finally, we pass that template into our modified mode, and the output is the resulting proc that was built. And we can see how each of these things got converted into the statements that build up the output. Now let's add back the compile step manually and run some substitutions through the template to see the content that's actually produced by the process. Now, if we shift the view of the proc generating code back so that we can see all of it, we have the entire process on the screen, and we can look at how each part relates. The first thing we can easily see with our generated proc is the process of how content is actually formed. It all starts with this magic underscore underscore O variable that I assume stands for output. That gets defaulted to an empty string if you didn't provide a string of your own when you invoke the template. And then lines like this add on to the output and slowly build up the response. In the end, just before the proc exits, the O variable is returned for as the result of this process. So it's just a simple string, some concatenations, and the returning of those contents that is the process of template evaluation. It should also be easier to understand the flow of variables in this form. When we create a moat template, we tell it which variables are involved in the template. We give it a list of names. Then when the template is invoked, those variables come in a hash, assuming any is provided. If not, it will be defaulted to an empty hash. Now that iterator that we studied before creates a series of lines like this at the top of the template, pulling those values out of the hash and assigning them to local variables. Then later, those variables can be used in flow control expressions to repeat content or make it conditional. They can also be used in interpolated expressions so that the value of the variable is actually added to the output. We can also now trace the various types of template data through the flow of ending up in final output. For example, the first kind of template data is just raw text that's passed through pretty much as is. A line with some unrecognized special content in the template ends up going through this branch of the case statement that uses a method I don't see very often on string in Ruby called dump. Dump gives us an inspect-like string. I'm not sure if they produce exactly the same string or not, but dump's documentation says that it will escape all special characters like \n and stuff like that. Also that it will convert any non-printing character to a numeric escape. I'm not sure if inspect will do that by default or not, but this guarantees that your content will get passed through no matter what it is. And that ends up as these lines that just directly add to the output unadorned in the generated proc. And finally, it ends up in our template as is, exactly the way we typed it in because it's passed through the process. Control flow lines are different. They start with the leading % sign, and that signals this branch of the case statement to insert the rest of the line verbatim in the generated proc. Now, because the proc itself is Ruby code, that means that you are just adding Ruby code to the proc. And so if you are using something like a conditional or an iterator or something like that, you're going to modify the statements that are being added in the template that add to the output. By doing that, you're going to actually change the content of the output, which is how a iterator like times can end up generating 3 lines of output because it repeats that add instruction 3 times. Now, it is worth noting that the n times do I line itself is nowhere to be seen in the output because that content is just discarded. It's merely a piece of the proc that generated the output. The third type is interpolations of values. So we give it the name of some variable or even a Ruby expression if we want. And that ends up going through this branch of the case statement where that item is evaluated similar to a control flow expression, but it's appended onto the output. You notice that we have to convert it to a string when we do that, just to be sure we don't get type errors. If the expression results in some kind of number, for example, as it does in this case, then you wouldn't be able to append the number to the string. So converting it to a string ensures that it will fit into our content. And then that just shows up with whatever value that expression resulted in and the final output. My new understanding of this code makes me want to try a few things to see how it works or if I can possibly improve it in some ways. First, have a look at these lines. The purpose here is to copy the variables out of the hash into local variables. And that's done with this form of string formatting that Ruby provides, kind of like sprintf and other languages. The string formatting takes some string that has these placeholders in it, %s meaning string, treat the value as a string. And then on the right side, we have this array of values, and the values are what gets substituted into the string. So the first one, we just want to end up with the name, no matter what was passed. Some common variable names might be symbols or they might be strings, for example. Both of those, when treated with a string, will lose whatever adornments they had. So, symbol ABC, colon ABC will be the same as quote ABC, quote. It'll just come down to ABC on the left side. Then in the second value in the array, inspect is called so that we get the Ruby representation of that thing. So colon ABC or quote ABC quote. And that's what gets stuck in inside the indexing of params there. It's a minor complaint, but I don't like this line because the format string is supposed to say how the format content is inserted into the string, and the data values are over on the right. But there's a little bit of hocus pocus going on here, since the second data value is actually the same as the first, but it's being changed so that when it's interpolated as a string on the other side, or inserted as a string, it will be different from the first string of the same variable. I think that's a little tricky, and I want to see if I can improve it. Of course, if I'm going to muck with this code, I need to first get it back in working order. I can do that by removing my changes and making sure the tests still pass. For the change I want to make, I'll begin by deleting the call to inspect. Then we can run the tests again to verify that they are broken. They are, as we expect. Luckily, the fix is trivial. In format strings in Ruby have a escape that means give me the inspect result of this value. So we can just ask for that specifically. You can see that fixes the test. Now I want to try a few simple experiments to cement in the understanding I've gained from working with this code. For the first one, I would like to see if I can actually access variables both through the local variable scope and through the params hash, like I think I can from reading the code. So I'll just type out a template that shows it both ways and see if the result is what I expect. Sure is. For my next experiment, I want to try to append to an existing string. It looked from the code that was an easy thing to do. And if you can do that, it means that templates can actually be combined and mixed and matched. So I think that's something I would like to try. The way to do that is simple. Just pass the start of the string to the call with your arguments. And as you can see, that too works. One last experiment. Now that I know of the existence of the __o variable, it seems like I could have Ruby code add to that variable anytime I want, any way that I want. I'm not sure if I can think up a practical use for that, but it seems like a cool thing that I just want to try. So I'll write a new template that uses some code that shouldn't end up in the output, but in that code, I will try to push some values onto the output variable. And the hope that the result I expect to see is that when I call it with a variable set to trigger that, the output will be there, and when I call it with a variable set to exclude that, it will not be there. And that's exactly what we get. Good to know. Okay, seems like we understand the parsing process pretty well now. Really, the only other main method in Moat is compile, so I guess we're ready to take a look at that. This really does two things. One, it instance evals the generated proc that we've been playing with so much. We've seen that in action quite a bit since we've been calling that proc to do the various tests that we've done, so that shouldn't be too much of a surprise. The interesting bit, though, is that that instance eval happens on a context object, which is passed in the beginning to the parse method. That context object is the scope that the template will be evaluated in. Therefore, if that context object provides some methods, say, then we should have access to them in the template. Let's give that a shot. I'm just going to make a random object here that has some data accessible via method, doesn't really matter what. Then if we pass that into a Moat template that takes advantage of that data, we can see how context works. It gives us the ability to request data from specific objects because the template is evaluated in the context of that object. Now, this is one thing Moat does that I'm not sure I like, and that's that the context is passed in to the parse method, and then it's tied to the template itself because parse calls compile. So you can't parse a template once and then apply it over and over again in different contexts, which I think would be a neat feature. Now, to do that, I guess you'd have a two-step, parse and compile, whereas this kind of combines it as a one-step, but then you could just be concerned with the context in the compile step, and that would allow you to only pay the penalty of figuring out the template once and then using it over and over again for different objects. But that said, trade-offs, and still, we understand how the context works at this point, which is the main goal. There's only one chunk of code left in the library, and that's this set of helpers included at the bottom. These look to me like how you might use Moat with some kind of web framework, where you were using it to render your views. Although I'm sure you could use it in any circumstance, but the big difference here is that they work off of a file instead of a passed-in string. So to me, that feels like web usage where you have view files. And so how this works is you can, mix this module into whatever you like. You have this main interface method Moat that takes a file and a hash and optionally a context. And then it reads the file to get the template. So the template comes from out of the file. And the hash becomes the name of the variables using the keys and the actual data that's passed in through the file. So this is an all one-step, build it, run it thing. There's no multi-stages here. This is pull the data and run it. It does use a cache, which it does with this thread local variable, which means that each thread would have its own cache, and you don't have to worry about them messing with each other and having shared memory conditions. But it's this cache for the file being evaluated. So the first time you call this, it's going to read the file, build the proc, and all that, and then that proc gets saved in this cache. And on subsequent calls through, you wouldn't do that read and compile step again. So you'd skip past it and only have the second step, which actually triggers it. Now, that triggering code uses one of my favorite features of Ruby's Lambda, or proc, same thing, proc and Lambda. And I want to show you what that is. I suspect most of us know that you can trigger the execution of a proc or Lambda object using the call method. But there's an alias for this operation that looks like indexing on arrays and hashes and other objects. This set of brackets over here is actually using that. So when you see params passed in here, it's being passed to the proc that Moat returned, and it's actually triggering the evaluation of the template. What I really love about this feature is that because it has the same interface as a hash, say for example, you can swap them out without affecting the code. So maybe you use a hash in some places, maybe you use a lambda, maybe you change your mind and decide you need more complex logic, so you switch to the one that lets you include arbitrary Ruby code. And this shared interface, I think, is a powerful thing in Ruby. Alright, we've played with this library long enough. It's probably time to get a look at what those tests actually look like. Before we do, we should make sure they're still running, and they are. That's great news. It's probably worth noting that a lot of people like to start with the tests, and I do too when reading many things, but when reading these smaller libraries like this, I find that making an initial pass through the code to see what I can glean from it gives me a great grounding, and then I can fall back on the test to see nuances or things I missed, and things like that. And I feel like I learn more that way for giving it my own try first. With bigger code bases, I can try to do the same thing, but often I'm overwhelmed and lost when I jump into the code, and so it's not as easy for me to pick it apart and realize what different things are accomplishing and stuff. So on the bigger code bases, I often will start with the test suite and move my way in, but that's just a difference I've found when working with small libraries like this. Okay, it's time to wander through these tests and see what we can learn. So I'm just going to visually scan here and see what jumps out at me. Actually, the first thing that jumps out at me is that there are 3 tests right in a row dealing with empty lines. Seems like that's kind of a pretty big concern of this initial set of tests. And that jogs my memory back to when we were in the code itself. Let's see here. Yeah, down here in the regex, we had this part of the pattern that matched blank lines, and I didn't initially know why that was there. And I guess now I know that it has something to do with this library and its handling of blank lines. So I'm going to assume if I shut this off, I can now comment out pieces of a regex thanks to my switch to extended mode and run make. Then we're going to see some failures, and we do. So that's interesting failure. There we have 3 new line characters does not equal 1 new line character. So something swallowed some new lines. In my opinion, that looks like a bug because there are only 3 things that could have matched as patterns, and that should be a line beginning with a % or a set of XML like tags or the double braces. And those aren't involved here. So I hope they're not involved here. Maybe I should verify that. So I'm going to come back over here and shut off those options as well. And let's do it again. Hopefully we get the same failure. We do, which is good because that means we're severely narrowing down where the issue can be. Now there's only one thing matching in our pattern, and that's obviously breaking things. Let's see. I would like to see what the terms look like on that busted example when they come through here. So I'm just going to add an arbitrary print statement in here to kind of peek in on things and see what I can see. All right, so the terms, that is also interesting. We can see the percent sign and the true and the percent sign and the false. Even the new line at the end, I'm guessing. Let's look at what that content was again. Yeah, there's a new line at the very end. But there are several new lines interspersed in that example that are disappearing. And we're actually ending up with empty strings in the terms array that I would not expect to see there. So something is eating our new lines. And as I said before, we've rolled it down to very few things. Now I see it. Okay, this is interesting. This is a kind of regex problem here. This code uses \s to match white space. And \s actually includes many kinds of white space. The normal space, we have tabs, new lines, and then more esoteric forms like form feed and vertical form feed or stuff like that, I believe. But what this code is actually trying to do, I believe, is to say some line beginning with possibly some white space in front of it, but a percent sign. And I think when they say that possibly some white space in front of it, they're referring to things like space or tab, but not to new line. So what happens is in the content, the pattern that matches percent lines is taking the percent line and the new line before it, because it matches at the beginning of the line the new line's on. That white space thing swallows up all the white space going forward, including the new line, until it gets down to the next line where it finally matches the percent sign. So it's actually eating multiple new lines and percent signs, and that's interesting. So the way they chose to fix it is to, I'm going to remove this print statement here now that I understand it better. And I'm going to reactivate these because they're not even involved. Okay, so this is the fix here. A blank line followed by a new line. Or the beginning of a line followed by a new line. In other words, a blank line. But that is not a complete fix, I don't think. So let's turn it back on and see if we could break it. We should be back to a working state, but let's go have another look at that test. And here's the problem right here. So now this chunk in the beginning gets pulled out by that blank line case, and therefore the thing still parses correctly. However, what if it was a little bit more complicated blank line? Like, what if it was a space and then a new line? And if we come down here and go back, a space and then a new line, this is not going to match, I don't think. So let's try make. Yes, and we get a failure. And so here we see that a new line has again been swallowed. And the reason is that now the blank line case no longer applies because it will only match the beginning of the line immediately followed by a new line. But this, quote, blank line is actually a space on it and then a new line, still a kind of blank line. And once it runs into that, then it can't parse that out of the special case. And that makes it fail when it gets to the percent line parsing. So we've kind of exposed a bug in that the fix isn't really perfect here. We could do this a couple of ways. We could allow for white space in that blank line scenario, but to me, it's the whole blank line scenario that's the actual problem. It's matching something we don't want it to match, I think. I'm going to try and shut that back off. I'm going to try and fix the real problem. I believe this is not intended to match all white space. And I believe it's just intended to match like a space and a tab. I can't use a raw space in here because I turned on regex extended mode, so I'll use the Unicode escape for a space to get one that way. Now if I do this, it will only match space or tab. That will stop it from swallowing new lines. And if we do the same thing over here, hopefully, aha! Now our test passed and we could remove the special case. So perhaps this is a better solution. I'm not 100% sure what the author intended, but it could be that this fixes the regex to match the actual pattern we're looking for. If that's the case, then that whole blank line special case up there could be removed. And that's interesting. We've kind of taken an interesting detour here about the dangers of regex matching and what you can swallow up. But I think this regex might be preferred. Not 100% sure on that, but we're going to roll with it for now. All right, back to the test. What else can we see in here? After the empty lines, we've got some flow controls, final new lines, etc. Okay, this is a double-quoted string with the interpolation stuff in it, and then inside that there's a double-quoted string with stars in it. So that's the second one is a Ruby string. It took me just an instant there to grok that, just looking at it. I think this might be a good place to switch to a Ruby string, a different type of Ruby string. We could just use single quotes in this case. I think that would work just fine, and it would allow me to remove the escaping. Usually, though, when I have a double string and I can't use it as a double string, I just go ahead and immediately switch to the Q syntax, the choose your own delimiter syntax. Usually I use this with braces, which might not be the best case here. It should work because Ruby is very smart and will look for the proper nesting of braces. So it does know that it's the third closing brace that actually closes the string. But in this case, that kind of confuses what's the template and what's the string. So maybe just choosing some other delimiter like an exclamation point or something that has no special meaning here would be a little better. And we get rid of the escaping. Yeah, okay, well, anyways, just a random idea to get rid of the escaping there and make what's going on a little bit more obvious. Okay, this is... Okay, so we have a here doc here. That's the less than dash EOT starts end of template, I assume is what that stands for. That starts Ruby's here doc. The way here docs work, if you haven't seen the syntax, it's a little esoteric, but it's a string literal that says my string starts on the next line and then runs until you find a line generally with just the HereDoc token on it. In this case, the dash option was used before it, which means the HereDoc token can be indented. Normally, that's not the case if the dash is left out. So we have this template in here. The template has a bunch of white space at the beginning of it due to the fact that it's indented. So the G sub call is going through and stripping out all runs of 4 spaces, which is the leading chunk of space there. That's interesting, and I've definitely seen that before. I believe several Ruby libraries give you ways to strip the leading bits off of here docs, so that's just a syntax to be aware of, I guess. And looks like that style is used quite a bit. It's good because it lets you see the templates in actual lines without having to put a bunch of new lines in them. I like that. Just kind of scan down here and see if I see. Ooh, that looks like. I think that's a copy and paste error. You can see that the parameters the test parameters, it does a parameterized template, and then it goes through a couple of times, passing N3 and N4 to get the different sizes of output. And then this very next test multiline, doesn't look like it has any variables in it, but it's still using this N3, I assume because it was copy and pasted from the other test. So I'm going to disable that, try and make. Nope, I guess I was wrong. Oh, because I also disabled the call. Silly me. Let's take out just this bit right there. And if we try that, yep. So the N number there wasn't needed in those tests. It was just a holdover from the test above, I'm guessing, when it was copied. So, okay, that's an interesting minor fix. What else do we have in here? Quotes. Looks okay. Context. This is almost exactly the example we did, making a context object and proving that we can get to it via that context user because it's in the variable context and gets passed in as context. Which is a little bit interesting there. This test is a little twisty to me. The context option is passed in directly, but then the context is also passed as a parameter, and they end up going through the parameter. So I'm not sure that this test actually tests what it says it does. For example, couldn't we just delete this since it's the context, and wouldn't that have the same effect? The answer is yes. So I'm not sure that's actually testing what it's intended to test there. It looks more to me like it's testing a parameter. Here's something interesting. These next couple of tests look like they use Ruby's top-level binding as the context. This is a constant Ruby sets up for you when the interpreter starts, and it's basically access to the binding where your main quote-unquote code runs. And so they've chosen to set that. I wonder why that was used here. The only thought that comes to my mind right off the top of my head is that perhaps they wanted to keep from polluting the moat namespace with this user variable that's being used here. So now it will be thrown in the top level binding and it won't be stuck in any scope. I'm not sure what the value of that would be, though. They've already polluted it above with the n variable and didn't take the precaution there. So I'm not sure why top level binding's here, but it is an interesting point to point out that you can get to that top level binding in Ruby if you need to using that magic constant. Curly bug. Interesting. This sounds like, remember in my sidetrack on the double braces and escaping them and stuff, I talked about how you could possibly run into a bug if you had multiple iterators nested inside of each other and you forgot to put a space between their closing braces. It might be possible to run into some kind of bug. I wonder if this is a case where they did run into this. Maybe we could use some archaeology here to figure this out. If we git blame this line, looks like this is this is the commit. Let's see, is that right? Yes. And those lines were all added in the same commit, which is kind of interesting. Let's have a peek. See, git show, Replace $ opening brace to closing brace with double opening brace, double closing brace. Interesting. So for some reason, the templates used to use $ and then braces, and apparently, for some reason, it was decided to go a different way, and all the changes were made throughout the system to switch from those two styles. And this test was added. This test was added all new with this commit. So it looks like they did run into some kind of bug with template parsing that was too common or something with the $ braces. I'm not sure what that is, but there was some test added, and this was the switch to the double braces. So not the bug I was talking about, apparently, but a different scenario where it was too easy to run into the closing brace. Probably with the use of a simple iterator, right? If you had the $ opening brace and all it's looking for is the first closing brace to come after that, then it would be very easy to end it with a simple iterator. So by doubling them, they've lessened the chance of that happening. That's my guess. I'm not really sure. I'm totally guessing there, so I could be wrong. But it's interesting to know that it used to use a syntax like that. Here we finally see the XML style directive discussed. A multi-line style directive, and they use it to do some arbitrary code, build up a result, and insert the result. That's interesting. I'm not too sure what the value of that is. This is the first time we've actually seen it mentioned, though. It's not mentioned in the README, and we didn't really play with it when we went through. I do believe the interpolation tags can be multi-line. Is that not right? Yeah, we're in multi-line mode there, and we have a period, so we can match it. So yeah, I do believe the straight-up double brace would do it. So I'm not real sure what the value of an approach like this is versus just using because I guess the double brace itself, you would need to make sure you return the right value at the end. But that's interesting. Or this can be for just big code that you need swallowed up, for multi-line code that you need swallowed up. So that's interesting to know that that's an option. That's pretty good. More XML directive. It only matches their special tag. It doesn't match the normal XML directive tag, which is good. And then it looks like we're getting into testers of the helpers. So we're calling that and loading the files. These are the other files we saw in the test directory. I'll open one just to have a peek. So yeah, just a simple template file there. Passes through in here, and they try it out. Gotcha. So user using that, and more with top level binding. And that's the end of the test. Okay, so that was worth it. That was definitely worth a pass through. We saw some complexities of the library, maybe some way it's changed over time. Maybe even found a better way to handle the regex due to the empty line issues that they've had. Yeah, I think that was definitely worth a pass. Time well spent. We've pretty much concluded our tour of the Moat library. But there are a few more bits and bobs here in the source that maybe we could glance at real quick. Let's get rid of the stuff we've been playing with. So we can see there's a bin directory where there's an executable. We can take a quick peek at that. A lot of just usage information here. and then a little bit of code for checking to see if we need to display the usage. The argument parsing, it looks like the template's the first thing, and it makes a hash out of any other arguments, so you can pass variables through to the templates. And then it just uses the helper, which we've seen. So we can invoke this pretty easily, probably just to try it out. We saw a template file in the test directory, so we'll just use that one. And that doesn't work because of the require. Yes, that's right. It doesn't use a require relative. We could get around this probably by using Ruby and putting the lib directory in the load path. There we go. So that gets the template loaded there. So yeah, that's very straightforward. ERB also has a command line tool like that, I believe. So no big surprise there. Let's see what else we see in here. What's in the benchmarks directory I skipped over. Let's run. Wow. Erubis, Hamel, Tilt. Okay, so this is a bunch of comparison code. Slim, complex view. I don't believe these were in the dependencies, so if you want to run this code, you're going to have some installs to do, I guess. And this is pretty lengthy here. But I saw, wasn't there a results file? So you don't even have to run it yourself. And you can see how Moat compares. These are rehearsals. Moat looking pretty good there. 1's 2. Oh, and then it explains what each of the numbers are. So 1 would be the uncached, templates parsed every time. 2, cache benchmark, the template's not parsed every time. 3, compiled, parsed before the benchmark, and the generated code. Pretty fast. Okay, interesting. So just if you care about the raw speed of templates, there's some information you can look at, which is nice. What else do we have? And an extras directory that we haven't glanced at. Syntax file. So if you do use Moat and use Vim, then you can load this and get some syntax highlighting inside of Vim. No love for Emacs, though. Oh, well. That's great, though. All right, and that concludes our tour of the Moat library. You've seen the whole thing. That's one of the advantages of working with these smaller libraries, is that you don't have to take large chunks of them on faith. You can actually poke around at everything, and we've done that. This concludes our tour of the Moat library and our first look at what the lesscode ideals have to offer us. Thanks for supporting Codalyzed videos. I hope you'll join me in the future for more code analyzing adventures. Until then.